Alright guys, so this is all that I want to share with you about the algorithms. Okay, now we're going to jump into the practical exercise for the threads, and once we get familiar with threads and see how we can actually be more efficient and code more efficient using threads in Python, then in the future we're also going to implement those algorithms. Of course, the only way you can implement those algorithms is, of course, using threads. Okay, so if you have your laptop with Python and PyCharm installed, you can work on it. If not, you can work on the lab pieces. I even advise you to work on the lab pieces because then you're all going to have exactly the same environment. So it's going to be a little bit easier. Okay, so also, as always, the code that I'm going to write today is also in the Blackboard under the course documents. Okay, so you will be able to assist at any time, even though if something doesn't work today. Although I'm gonna go around and make sure that everybody can run the code. Alright guys, so all of you can open PyCharm. Okay, and let's create a new project. So threads are normally something that is implemented in the basic Python distribution, so we shouldn't need to install a lot of libraries. Maybe we'll need to do one actually, but I will show you how. So let's just create a new project. Okay, so I'll call it threads 1 to 3. You can name it how you like. Actually, on the lab pieces, I would advise you to create in the J folder. As you know, in the J folder we can execute things where we cannot execute like nowhere else. So make sure it is in the J folder. Okay, so the idea today is, first of all, I'm going to create a simple script where we're going to access a few pages over the web using Python, and then I'm going to implement threads, and we'll check the time, so we see how much time it takes when we use threads and how much time is going to take without threads. Okay, so you're gonna see how things get improved when we do that. Okay, so I'll create two files here. The first one is going to be called base.py. So here we will implement the code without threads. And then the next file that I will create is going to be called tr.py. Don't call this file threads because there is a threads package in Python, so you might get import errors if you do that. Okay? Alright, so firstly, I will show you what happens when we don't use threads, and then we're going to implement them. So I will import time, and then I will import requests. Okay, so in PyCharm, if you see this underlined in red, you can install the package from here. Okay, or you can go in the console and do pipe install requests. It's the same thing. Okay, so after that, I'm going to create a dictionary. So we're doing things in PyCharm. You can go from the lab PC and follow. Yes. Okay. So guys, I know the lab pieces are a little bit tricky. So if you have issues installing requests, what you can do is, if you go here, see in the bottom corner, you can click it. You can select interpreter settings. Okay. Then you can click the plus button and you can type here requests. Okay, that way you will not need to do it manually. Okay, so you can just select it and click install package. Alright, I will go around and make sure that everything works for you. Okay, let's just get through the base example. Okay, so here I'll create a list of URLs. Okay, so URLs will be equal to a list, and here I'm going to write a few URLs. So let's say https python Okay, then let's do another one, https google.com, https youtube.com, and of course you can do whichever address you like. Okay, it doesn't really matter. Let's do another one, https wikipedia.com, actually it's .org. Alright, so I will leave them 4. Actually it doesn't matter even if some of your URLs repeat, so I'm just going to copy them and paste them below, so I just have more URLs. Okay, it doesn't matter. Alright, now the next thing I'll create is a function that will download the content of these websites. So with the request library, you can go to a web page and you can simply copy or download its HTML. And this is very simple. So I will do def download content. This function will take a URL, and then the response will be equal to requests.get, and I will pass the URL, and then I will return response.content. Okay, so what's happening here? The page response or the HTML file is going to be equal to request.get. So this is a standard function of the library requests. We're going to pass the URL that comes to the function, and then we're going to return response.content is going to give us the content of this website. It will return it. Okay. Now, next thing, I will create the main Python function. So if name equals main, okay. So when we run Python code, it always starts from this line. Okay, so here's where our code will start. And the only thing that I want to do here is I will do for URL in URLs. So for every URL in our list, I will do content will be equal to the function, and then I will pass the URL. Okay, so the content variable will be equal to the content of the URL, and after that I'm just going to print the URL. So I will do print. So I will print the length of the website content from URL. Okay, so I'm just going to print how many characters our URL has, because if I print all the information, you're not going to be able to see anything here in the console. Okay, can you see on the back? Alright, so the only next thing I'm going to do is I want to also show how much time did it take me to get all this content, right? So you can track time in a very simple way. Actually, if you plan to learn Python or use Python, this is a very simple method to estimate the time between certain lines of code. Okay, it's a very simple one. I use it very often for debugging. So you can do start time equals to time dot time. Okay, so I add a timestamp here, so I record how much time was the time here at that line, and then after I execute the for loop, I can do end time equals time dot time. Okay, so now I also have the timestamp from this line right here after the for loop. So obviously the time that was taken by the for loop was end time minus start time, right? So this is what I'm going to print. So let's do time taken, and here I will just do end time minus start time seconds. Okay. So then if I run that, you can see that the code will check how many characters each page has. Okay. And then it will show me how much time it took to get this information. So obviously, to assess every page, we need to do a request to the server, then we need to get the response from every website, which obviously takes time. When you do it for how many? 8 pages or so. Alright guys, so all of you now have the project running, as we saw. Now, the next thing I will do is I will implement threads, okay, and make sure that we're spending now less time to code these websites, and this is going to be because we're going to try to assess them at the same time. So in order to be able to do a good comparison, what I will do, I will just copy everything we have so far into the tr.py. Okay, and now we're going to implement threads. Okay, so the first change I will do is I'm going to copy this right here, and I'm gonna put it inside a function. So I'll delete this return, okay, and I will just do print, okay, response dot content, okay, and then the characters from the URL. Okay, so now we're gonna print the content directly in the function. This is one of the changes that we need to do. The next thing I'm going to do is I'll go here under the time and I'll write threads equals to an empty list. So the idea is that for every URL we're going to create a new thread, and then we're gonna run all the threads concurrently. Okay, so we're gonna create a thread, started, create a thread, started, create a thread, started. Okay, that way we will not need to wait until one website is assessed before assessing the next one. Okay, so let's see how that's done. Now, after we create the list, then here, you know, we're going into the we start looping over every URL, and instead of printing this, we no longer need to print it. Okay, and I will also remove this line as well. So now let's create a thread. So I will do thread equals to threading dot thread. So when you create a thread, you need two elements. The first one is the target function. The second one are the parameters that you want to pass to this function. So let's add them. Let's add target equals to download content, okay, and make sure you pass the function without the brackets or the parentheses, okay, not like this, just the name of the function. This is all you need. And after that, as I said, let's pass the arguments. So let's do args equal, okay, and obviously here you need to pass only the URL. So there is only one argument we need to pass to the function. So instead of writing download content and then passing the arguments in the function, we can create thread by specifying the function and what parameters I want to pass to the function. Okay. So here the thread is created. Now, if I start this, okay, so if I run this function right now, you see that nothing will happen. I just get a display of the time, but obviously we didn't get through any URLs. And this is if you, yes,
Just check. I may have missed it because it was like right everything. We have to import threading, right?
sorry.
We have to import threading.
Yeah, yeah, so yeah, for me it happened in the background, but yeah, you can go on the top and import threading. Okay, so you don't need to install it because it's a basic Python library. Okay,
Yeah, I was just getting ready to grab it.
yep,
It wasn't imported yet, so I missed it.
exactly. So now, once I executed this, you saw that nothing happened, right? And this is exactly what we were talking about last time. So in trading, there are a few stages. Okay, so stage 1 is creating the thread. Stage 2 is starting the thread. Okay, so I showed you last time create, start, join, and so on. So now let's start the thread. Okay, let's go right here. Okay, so first of all, before starting it, I'm just gonna add it into our threads list. Okay, so I want to add identification of the thread to have it in the list, because later I would want to use this list in order to be able to stop the threads altogether by looping over this list. Otherwise, I will need to specify thread 1, thread 2, thread 3, and so on. Okay, so we can do threads, which is our list, dot append, so we add an element to the list, and then I'm gonna append the thread. Okay, and when I append the thread, this will not only append the name, it will append all the information about the thread. Okay, we can also display this so you can see. Okay, so after we did this, which has nothing to do with the thread execution, then we can write thread dot start. Okay, so at this point our thread will start executing, and once we reach the start keyword, our thread will start executing, but before finishing executing, it will immediately continue with the next lines of the code. Okay, so it will not stop there and just wait. This is the idea. So now we can continue with our code. So after the start, as we talked before, the final part in the thread life is the join. So when you write a join, this means at this position of the code, I want to wait until the thread completes. Okay, so I don't want to move away from it until it completes. Okay, and if you write join at multiple times, okay, for many different threads, it is all going to be read as one block. Okay, so we're going to wait for all of them at the same time. They're all going to be executing. And here is how you can do it in a short way. So I will do for thread in threads. So now our threads list has the information for our threads, correct? So then I will simply do thread dot join. So obviously this is a very short way to do it. This would be the same as me writing thread 1 equal to this, thread 2 equal to the one for the other URL, and so on until thread wherever, thread 10, and then I'll have to thread 1 dot join, thread 2 dot join, and so on. Instead of this, I can do this automatically. So now the amount of threads that we start and we join is going to depend on how many URLs we have, right? The more URLs we have, the more threads will be created. The more threads are created, the more threads will be joined. Okay? So that way, for example, remember last time you asked me about, I think in your company they didn't allow more than 500 threads, something like this, right? So for example, here it is going to be very easy to increase the number of the URLs. You can add one URL and you can multiply it, the URL list, by 1 million and see if you can support 1 million threads at the same time, right? So we can see what's going to happen. All right. So now we click joint, okay, and the rest of the code can stay the same. So here we have the time. Now, I'm going to increase a little bit the number of websites. So I'm just going to copy and paste them multiple times. Okay. And after that, actually, let's copy also this for the base. Okay. So now we have the same list. Now, firstly, I'm going to run the base again. Okay, so they execute one after another. Now we're waiting. Okay, so it took about 9 seconds. And imagine I'm not adding any time sleep, so I'm not adding any waits in my code. This is just how much it takes to go to the servers and to access each website multiple times. So it takes 9 seconds. Now let's run the tr.py, so I'm going to run it. Okay, and this took 0.69 seconds. Okay, so obviously here you can see really how powerful threads are. Multiply this by multiple operations into the operating system, of course, or in your application program, wherever you want to write. Obviously, this is going to save you plenty of time. All right, so last thing I want to try just for fun is I'm going to multiply this, okay, by 1000. Okay, so this should create, I don't know how many there are. If there are 20, it should create 20,000 elements in my list. Okay, so I'm just gonna run it, and as you can see, my computer doesn't do all of them at the same time, right? If I create 20,000 threads, then everything should be done in less than a second. So in fact, the computer selects just a number of threads to run, then selects another number of threads, then it runs them, then selects another number of threads. Okay?
Like some of them look.
Oh yeah.
As if it doesn't actually space them out.
Yeah. I also wouldn't be surprised if I start getting errors. Oh, you see? It stopped. So also my laptop now is like a little bit slow.
Exceptional threading.
Yes. And as you can see now, my laptop started throttling because there are too many threads going. Okay. So I'll try to stop it. So, okay, I stopped it. So now the resources hopefully are free. But you can see that there is really a limit. You cannot just run unlimited number of threads and expect your computer to cope with anything. If you run, as you can see, many of them, it will start throttling. So you always, when you build applications, you need to find the best amount of threads for your specific application. Now, with websites, I would expect to be able to do a little bit more threads because I'm just printing whatever is on the websites. But for example, if I use an API, whether it's operating system API or a web API, what I want to do is really to find the exact number of threads I need, because the APIs tend to be slower comparing to the websites, right? So this is a good example where you can see that.